Hey, how's it going everyone? Today we're going to be taking a look at how to handle user inputs in your game. So if you are making a game and you're trying to keep track of, alright, how do I control the player? How do I control the menu? How do I navigate from this room to this room or this stage to this stage and handle all of your user inputs? So when the person interacting with your game, the person playing your game is using the keyboard or the controller or the mouse, and how can we best manage that input? Now you can handle this many different ways. However, here's the way that I tackle user input. Alright, so starting off, we're going to have a player object and a collision object. So I just created a blue box, called it SPR_player, gray box, SPR_collision. We're going to most likely delete this code later on, but let's do HMove for horizontal move. And let's say your code looks something like this, right? Keyboard, and let's say left, and then you have vertical move, V move. So I'm in the create event, just creating these variables to kind of show you guys. Okay, and let's try up. Okay, so you may have something like up equals to keyboard check up key, down equals keyboard check down key, right? And then left, and then right, etc. What I'm going to do here, mostly because we're not going to be using this code later on, this is just mostly for reference. I'm going to start off saying horizontal move and vertical move. So in this case, I'm referencing a top-down game where you can kind of move up, down, left, and right. So I'm going to say right minus left is equal to your horizontal move. So if the player is pressing right but not left, they should be moving right. So +1, so they should be moving right. If the player is not holding right, and this is 0, but they're holding left, it's -1, 0 minus 1, -1, so they should be moving left. And then the same thing with the up and down move. I'm going to go here and say, so now if I'm moving up and down, so in GameMaker things are a bit different when you're moving up and down. If you're moving in a negative direction, you're moving up. If you're moving in a positive value, you're moving down. And so next up, we're going to use a built-in function called move and collide, and here we're just going to say HMove VMove. So on the very bottom you can see that this is kind of all of the different arguments that this function takes in, and I'm going to toss in that collision object, and then all of these others are optional. You can also move the mouse up here and kind of learn a bit more, or you can also open up the manual and read a bit more. So what are we doing? Well, all we're doing is we're just getting user input, and since this is inside of the create event, we also need to bring it in the step event, so that way every frame of the game can actually register what we're doing. And so now we should be, if I were to hit play, so I went inside this room, I just tossed in the player object and the collision objects and kind of stretched them apart just to kind of show the game a bit, so we can actually have an example of what's going on. And so if we go back to the player, we're going to see that this is only going to equal either 1, 0, or -1, 1, 0, or -1. And then in your game, you may want to multiply that by speed, whatever that may be, just to keep track of how fast you want the player to move. But this isn't a tutorial on how to create an top-down RPG game or something like that. We're just going to keep it like this, and I'm going to start moving, and as you can see, the player is now moving. We should have that move and collide logic here. Awesome. Just going to times speed, just hard coding a value of 3 for the speed. There you go. Alright, so as your game gets larger, you're most likely going to have more than just move up, down, left, and right. You're probably going to have a roll and maybe a dodge, like a dodge mechanic, an attack mechanic. You may want a pause mechanic, pause and selecting whatever mechanic. And so your controls are going to get a bit out of hand. If you are making a game, the player may not live in every single room in the game. So you may have your title screen, and you don't want the player to live in the title screen and then live in the end game screen and keep track of it that way. What you would want to do is you would want to have all of that input managed in one area. So that way, if you need to make an update or change or something like that, you can go ahead and do that. But what if we wanted to, again, add to it controller commands here, or some sort of mouse commands here. You could do it here, which is perfectly fine. You can also create a script and put it in a script, which is perfectly fine, but it may get out of hand to manage. So the idea here, what we want to do is, instead of just creating and managing these particular actions or these particular controls in the player object, we would want to create our own new object. So first, start off by creating an object. I just called this one obj_input. You can call it controller, you can call it input controller, whatever. Actually, obj controls, maybe that's easier. Here, start off by making this object persistent, because you want to create the object when you're initializing the game, whatever having to be destroyed or recreated or anything like that. First off, what you would want to do is, let's say we were taking these controls. I'm just going to delete that and putting it here inside this new object. You can probably do this, the speed variable if you want to. Doesn't really matter here. And then these controls can go to the step event. Again, we want to keep track of the movement every single frame of the game. And so now the problem here is, if we're calling moving collide, these are now local variables to this object. So if I were to run the game, we're going to get an error because these variables are not initialized. If you wanted to reference them out, you may want to first check if the instance exists, which it should always exist if it's persistent and it gets created before anything else. So you can say if instance exists, obj controls, then the player can do whatever the player wants to do. So in this case, I'm going to drop this here. Let me put this in here. Go back to the player, and this is where things could get messy, because if the player instance gets created before the controls instance, you may come across an issue because the instance doesn't exist, and it could get messy. But I'm going to use the same exact example that I just did, but now I'm going to be referencing the object. So you can kind of do this. I would not recommend doing this, but you can say obj.controls dot, and we're going to say hmove times obj controls dot speed, and that's our first argument. Remember that we're going to be using 3 arguments, so this is the same as saying this, except we're now calling an object. And you can probably even get away with saying like with or other. That is the first argument. And the second argument, I'm just going to copy this, paste this, vmove, and then obj collision. So this should do the same thing. Let's see what happens. All right. So the exact same thing is taking place, and instead of keeping track of all of the control inputs inside the actual player itself, we are now referencing another object to do that. And now, if that player, for example, we had a second room, like a title screen room, we don't need to have the player present to use those controls. This is just an example of how that logic works, but this is a bad practice. And why is it a bad practice? Because we want to keep track of all of the inputs. We don't want to just keep track of this variable and that variable. We want the player should be keeping track of those variables. hmove and vmove. The player should have its own script to take these inputs and use some logic and do something with them. However, in the obj controls, what we really want to do is have every single control defined here. So we would want to say right is equal to whatever, up is equal to whatever, down is equal to whatever, left is equal to whatever, and this would be ideally what you want. Down and up. This would be ideally what you want, rather than this up here. And that is because you want to be able to use these controls when you're checking the keyboard and storing it as a variable. You want to be able to reference this outside the player. Again, you're in the title screen and you want to move through navigation or press pause and you want to move through the pause menu. In reality, what we would want to do, we want to go back to the player object and probably do something like this. H move, V move. And let me just keep those really quick. Just to reference them. Okay. And then here, and then down and up. All right. So let's go back here. I guess we can say speed equals 3. Just going to keep the speed of the player in the actual player object. Seems to make a bit more sense. So now what we want to do is take this logic here so that we can get rid of this. So now let's take it a step further, and what we did was we said, all right, OBJ controls is going to keep track of everything. So what is OBJ controls keeping track of right now? Well, it's first creating these 4 variables, and then now every step is going to keep track of whether or not these are true or false. And so every single step in the game, or every single frame in the game, if I were to press right, this would be true, the player would move right. If I'm not pressing right, the next frame would set it right back to false, so it'll be 0, nothing will be happening. Same thing with up, same thing with down, whatever. So now the player can reference what's being controlled, or what the user is inputting. And so here, I'm just initializing these variables. I can actually set this to 0 if I wanted, because it's just a create event. We're not doing anything special. So let's set this to 0. The player should not be moving upon creation. Instead, if we're keeping track of the controls input, what we'd want to do here is now we can go back and just say H move times speed, V move times speed, and then still keep track of OBJ collision. And also, I think I just deleted it, but we also want to keep track of this to know whether or not. Let's delete this up here. So things are probably seem a bit more complicated, but we're going to keep iterating on this. So what did we do? Well, we went to OBJ controls and we said, all right, let's create a variable for right, up, down, left. Went back to the player, and whatever variables that the player needs, we created it here. And then we said, all right, well, if the controls exist, like if the object exists, then we're going to reference the logic in the object, or the controls in the object, and then we're going to set it to this is the same thing that we've been doing, except a few extra layers here. So now if we press play, same exact thing. So we're back to where we started, except this time we now have an object that is keeping track of all of our movement, rather than having to recreate this code for every single object that is going to need this movement. And so we have other options too. Instead of referencing OBJ controls all the time, we can go back here in the create event, and you can also force these variables to be global. This is an option. It is a bit slower, but it's relatively unnoticeable. So you can do this and say, all right, I'm going to create these movements to these variables to be global, and then reference them throughout the game. Just going to copy and paste, to be honest. Okay, and now we're back to where we started, except this time, instead of putting in the object, I'm going to go off and say global. All right. And we're doing the same thing, right? Nothing changed except for the code. And as you can see, we are now, instead of referencing the object directly, we are now just using a global variable, which is way easier to manage, in my opinion. And so now what we can do is let's go back to OBJ controls, and now we can kind of get creative. So you can do this or type in or. And so let's say we wanted to add some extra logic here, because in the player object, we just want to do all of the extra logic and all of the extra controls and just move the player and do whatever. But as your game gets larger, you may want to go back and say, oh man, I should have added a controller input. I should have added touchscreen controls or this or that. And the cool thing is, instead of having all of the code inside your object or even in just like a script that you're referencing that's only designed for the OBJ player, right, your player object, now what we can do is we can go back to the controls. We don't really care about the player because the player's logic's already set up. The player is just saying, do this logic if this value is true or false, whatever. But now we can go back to OBJ controls and begin to do whatever we want. So instead of left, let's say we wanted to do keyboard check. I think that's ordinal and D, right? So now we wanted to take it a step further and do like WSAD. All right, and so the only thing we have to do is just make an update to this OBJ controllers object. And once I hit play, now I can use WASD on my keyboard, or the up, down, left, right arrow keys, and then we can kind of get fancy and say, or we can keep adding to it, right? We can say or gamepad button, I think, yeah, button check. I'll have to initialize a variable to keep track of if a gamepad is connected, and then which gamepad are we referencing here. We may want to add this in the step event when you're working with controllers, because the player can connect their controller at any time. You want to be able to catch that. Connected, and then device 0. Right, and we can also take that, put that in here. You can kind of add to the logic and also say, instead of saying or, maybe you can do another condition and say if gamepad index is true, meaning that device 0 is connected, or slot 0, then you can use this logic. For this video, I'm not going to dig too deep into that, just an idea for how you can continue adding onto your code here. The last thing I want to go over is, so this works perfectly fine, but an easier way to keep track of this as well, we can also use structs or global structs. So let's say we wanted to use a struct, and we're going to call this struct input. So here you're pretty much making an array. So what we can do is we can say write, and with any struct the syntax works like this. You have to do these kind of like semicolon things. Here we can just initialize it, up, down, left, right. I just like to use that. And then you'll want to assign a variable. We're just initializing it for the first time in the create event, so it doesn't matter if this is true or false, because it's just creating the variable. So in structs, what you want to do is you want to define the name followed by the value or the condition here. So we're going to say false, and then leave a comma, to continue going, false, and then the last one doesn't need a comma because we're closing off the argument, or closing off the struct. All right, so now what we're saying here is, instead of using these variables, and we can also make this global.input. So here, instead of saying global.write, we can now say global.input.write, input.left, input.down, input.up. Okay, so bear with me here. Same exact thing is taking place as above, except we're not adding that extra logic. We're just initializing it first. And so now what do we need to do? We need to go in and set these. So this is going to be the same as global input.write, input.up. I think that was, yep, input.up. Okay. So now if we run our game, we don't need this anymore. We can just junk all of this. We can also get rid of this for now. We're just not going to add those controls. Just comment it out. On your game, you'll definitely want to handle gamepad controls. Hit play. And there we go. Up, down, left, right. WSAD. We're back to where we started. Only this time now we're using a struct to keep track of the movement, and the movement's now being used by a object. That object is now persistent, and it can travel through any single game in the room. Even if the game's paused, if that object is still alive, then it can be used for controls. And then, so now you may be like, well, Matt, what's the point of having a struct if the other methods work just fine? Well, the cool thing here is when you're working with structs, it is easier to call your variables. Right now we only have 4. However, if you were to have like 20, for example, you may want to break them up into different pieces. What if we have a struct for movement, and then a struct for actions, and then a struct for maybe mouse movement? You can set them all up as one variable, which is awesome, and then just reference that one variable for everything in your game. So how can you do that? Let's take a look. Next up, we're going to be doing nested structs. So let's call this one movement. So we're going to do the same thing that we just did above. And now we have a new struct. There we go. I think, yeah, I guess this looks nice and clean. Okay. So now we just said, all right, well, let's create a new struct. This is called movement. And in here, what we want to do is we want to say movement, and then inside movement, keep track of all of the different movement variables. And let's say we wanted to do something for action. Now here we can say, and it's giving us an error because we need to use our commas again. Give me 1 second. Do a comma there. Attack 1, attack 2, blocking. Don't forget to put the commas. Okay. And then so on and so forth. Now we can just get creative and continue going on. So now we have a nested struct. So we have our global input, and then we have movement struct followed by an action struct followed by whatever else, right? A struct for managing all of your mouse movements or your touchscreen controls. And the cool thing too is that you can actually in code, you can say, well, for running on like a mobile device, only use these variables. For running the game on browser, use only these variables. You can kind of just like ignore the gamepad or the controller if you wanted, so on and so forth. So how is this going to look different? Now, since it's nested, movement.write, you now need to add movement here. And so yeah, it's an extra layer, but it's now a bit more structured. And I say that because now when you're calling global input anywhere in your game, you now have access to every single input that you've created at any time, and you can use it anywhere as long as you're keeping this object alive. So then we go back to the player object, and then now what we want to do is movement.write. Okay. Hopefully I don't have a typo, but we're gonna hit play one more time, and now we're moving again. So the neat thing about programming is that, or programming, coding, whatever you want to call it, is that you can actually tackle the same task many different ways. You can structure things differently. We didn't have to use OBJ controls. We could have used a script. We could have kept it all in OBJ player. OBJ controls could be used for other things. So long story short, the best way for me at least to keep track of controls is to use a struct, a nested struct, global input, have a OBJ controls object where you initialize it when the game first starts, keep it persistent, let it follow the entire path of the game so it's living in every single room at all times, and then start to break up your controls into different pieces. And you can even do other things here, like you can say movement 2. Let's say you have a new player, your game is multiplayer, for example. Now all of a sudden you may want to say, alright, well, let's use movement 2. And now all of a sudden this is very flexible. Anyway, that'll be the video for today. Hopefully you guys learned something. Let me know if you guys have any questions in the comments below. And until next time, I'll catch you later.